Okay, we're going to start with number 8. What number 8 gives us is it gives us the semilatus rectum for what the heck? That equals L, our semilatus rectum, and then it gives us 1.881, which is our delta. By looking at the graph, we can tell that it's a hyperbola. So we'll put HYP so we know. And okay, so what is the formula for a hyperbola? Do we know? Right. So because why is it y minus k squared? Exactly. So it's y minus whatever that is squared. What goes in the middle? Thank you. Minus x whatever squared with the two whatever those are in the middle. And now we find the center of our graph. So if you look at between them, how many points look like? Right. So the HK is 3, -3, -1, like I said. Um, which one? All right. So where does -3 go? So it's +3. Why is it +3? Thank you. Where does k go? And what is it? Thank you. All right. Now for the bottom part. If you look here, that looks like 4, doesn't it? But it's not. Because if you look at it closely, if you look at your graph on your paper, you can see it better. Uh, it's a little under the 3 mark on the top. So we have to do a big old equation to figure out what it is, right? So can anybody, so where does A go? Right. Okay. So what is the equation to find A? Thank you. All right. What do I put where? L, which is, all right. Everybody understands up to this point? Cool. All right. So we figured this all out. Anybody have that done real quick? 0.886, you said? Thank you. So A will equal 993. All right. So now, okay. So we know that A is right here, right? Of course. So that is the y-axis. So what that'll give us is if we square it, that'll give us whatever value we need for here, right? Everybody understands why that is? Okay, so squared, it is 947. Everybody get around there? All right. So now we have to figure out what this is. We don't know because we don't know where the heck the parabola square ends. So we have to figure that out by using Pythagorean theorem, of course. So what is the equation that they give us for Pythagorean theorem on the VIP? So what we need to find is b, right? So how do we rearrange that to find b? Okay. So we obviously know what a squared is, correct? Because we just found that. So that is 15.947. But how in the heck are we going to find c squared? Or find out what c is, even? All right. So c equals a plus delta. Okay. 3.993 plus 1.881. What does that equal? All right. Everybody understands up to this point why we did that? We have to square it, right? Which is 28. I got 34 on mine. Wait, Sam, what did you get? You got 28 point something? Oh, I heard somebody say 3.4 over there. Oh. So. All right. All right. So everybody understands how we found C and why we had to find C, correct? Why did we have to find C? To find B. By using the? Awesome. Okay, so what's 34 point la-di-da minus 15 point whatever? Everybody agree with that? Actually, no. Exactly. So it's 18.557. So that is your equation. Everybody understands that, right? Where did we get the plus 1 from? Where did we get this from? Where do we get that? And what's that? And that? Exactly. All right. Yes. I made a big mess here. I'm going to extend the page. Is that okay? All right. So now we have to find E, the eccentricity or eccentricity, whatever way you say it. E is very simple. C over A. And E equals whatever C was, which was, where did we find it? Over A, which was, and E equals, which is greater than 1, which confirms that it is a factor.
Hold on, pause one more time. There is a very fancy formula for E. Do it and double check that they're the same. By fancy, I mean long and complicated. The long one.
Oh, that's the one I just did. It's the same. I just did it. It's the same.
Okay, let's put it on there.
I thought that was the one.
Is that right?
Should work the same. Yes, over.
Delta?
That's it. Everybody punch it in and see if you get the same. Just to prove to yourself those work.
Which is greater than 1. Therefore, it is a hyperbola.
Let's now do number 9. Now, before you do number 9, everybody needs to read right here. For problems 9 through 16, assume that the focus lies on the origin. For convenience, use the standard orientation of the conic. Horizontal for ellipses and hyperbolas, and vertical for parabolas. So everybody, let's put a few pictures at the top. If this is the focus, and this is an ellipse, the center then could be over here, and the other focus would be on the other side. So my ellipse is going to look something like that. You with me? Because the focus is on the origin. You see that? So a hyperbola, might be good to draw these, would look like that with the center here. And a parabola, we're going to do this way with the focus on the origin that way. You with me? Okay. So, what? Good. That's my job. Okay, so here we go. Here's where, do you remember yesterday in the video you watched, we talked about E, and why do we care to know what E is? Well, for this problem, we don't even know the type of conic section it is, so we're going to have to find out E to tell us. They don't give us A and C, so we're going to have to use the harder equation for E. So everybody get started on that.
Wait, but it's different equations.
No, for E it's not. E is always the same.
Unless it's C over A.
Well, E is always C over A as well. For E, it's always the same. So just look at any of them, and I think it'll be 1 plus, I don't have these memorized. Is that L minus 2 delta over delta? Is that it? Okay, so start filling it in. Yes, that's always. L is 40.221 minus 2 times delta, which is 11.887, over delta, which is 11.887. So the best thing to do would be to type this numerator in first, divide it by the denominator, and then go back and add the 1. It's a little easier. 2.384. So E equals 2.384. Okay, hang on. So Christina says it's more than 1. Caitlin says it's a hyperbola. Xavier, can you explain to me why, since it's more than 1, it's a hyperbola? No is his answer. Could add somebody do that? Hold on. Let's see if there's somebody besides Jacob. Why is it that a hyperbola is more than 1? Matt, can you do that?
Yeah, because C, which is the distance from the center to the foci, is larger than A.
Which is?
Distance from the center to the edge.
Okay, I'm going to draw that out for our. So on a hyperbola, whoopsie. See if we can get that back. And we'll be okay. Okay, so on a hyperbola, the distance here from the center to the focus is C, edge to center is A. Whoops, that doesn't look like an A. A, so C long over short is more than 1. And since the foci are on the outside, C is always going to be larger than A in a hyperbola. That's the explanation you need to be able to spit out on the writing portion of your test. Hint, hint. Okay. Hang on. We're videoing. We don't need all of this. Say it again. See, because the foci are on the outside. The distance from the center to the focus is always longer than the center to the edge on a hyperbola. So a larger number over a smaller number equals a number greater than 1. On an ellipse, the foci are inside, so center to focus is smaller than center to edge. Okay, let's move on. So what are we going to write in part B? Okay, good. Now let's find the equation. Just like you did with Jacob, to write an equation out, you're pretty much going to need to know A, B, and C. So before we even start, let's go ahead and find A, B, and C. Always start with A. That's easy to remember. Start with A. Now, since I don't have any of these easy things, I'm going to have to go with the A that has the delta in it. And what is that formula? Over. Exactly. So A equals delta squared over L minus 2 delta. If you notice in an ellipse, it's different. So be careful. Once you determine that it's a hyperbola, flip to your VIP hyperbola formulas. Okay, so delta is 11.887 squared over 40 minus 40. Sorry. Hang on. 40.221 minus 2 times 11.887. Now, being careful, because you have to put, if you put the whole thing in the calculator, you got to have extra parentheses right there. And we should have gotten something like 8.591. Okay. Again, make sure you're in the correct part of your VIPs, because for a hyperbola, there's not a negative in front of the delta. Correct? For a hyperbola, delta is not negative. So make sure you're in the correct part of your VIP. So now we know A. Then you need to find C. The next easiest thing is to find C. You can't find B until you know A and C. Did everybody hear that? You can't ever find B until you know A and C. So let's go ahead and find C. Now, if you understand your picture, we'll go back up to ours up here. On this hyperbola, look up here. If we want to know C, which is that long distance there, we need A plus what? Delta. So C equals A plus delta. So let's go back. I'll put it here. C equals A plus delta. So that's 8.591 plus delta in this case was 11.887, which equals what? 20.478. I had a cough at the center. Okay. I'll remind you what we did earlier. The question was, how do we know if it's vertical or horizontal? And we remember when up here we read this, and it says, for our convenience on these word problems, we'll always do horizontal. And that's why we drew our picture at the top. Did you draw those with me? Yeah. Okay, so it's always going to be horizontal. So what she's getting to is the fact that we're going to put our X in the front. But I'm not there yet, because before I write this, we need to find out which letter do we still need? B. Now check your Pythagorean, because they're different for hyperbola than parabola. So for hyperbola, I always remember that it's A squared plus B squared equals C squared. It's my normal one. But since I'm looking for B, I'm just going to go ahead and subtract the A. So I know that B squared equals C squared minus A squared. So B squared equals C squared. Well, I see C is 20.478. And we're going to square it, minus A, which is 8.591. and we're going to square it. So pop that in, and we'll figure out that b squared is 340. I've got 345. 345.538. I have 550. So we're, as long as you have 345.5 something, we should be fine. Okay. Now, we're ready to build our equation. Now, here's the part that you've got to remember. The center. Isn't the center? It goes here and here. Let's go back up to our picture we drew. Where is the center? Careful now. Let me draw a better picture. I'll draw it right here. Our center is here, correct? What's the distance from the origin to the center? That's C, isn't it? So, and it's not ever going to go up or down on these word problems. So the center every time you can write this down, is going to be C comma 0. Why 0? Because we didn't go up or down. We stayed on the x-axis, and we know on the x-axis y is 0. Okay, so it's C comma 0. So let's go back up here. Erase that and that. So x minus C. Let's go retrieve C. 20.478. I'm going to need to start over. I didn't give myself enough room. So x minus 20.478 squared over what? Y what? Minus, I'm sorry, I said over. I meant minus y squared. And we don't have to move up or down, so there's 0. And you can put a 0 if you want to, but you don't need it. Okay, equals 1. Now, underneath the x is going to be a, because a always goes in the front under the first fraction, but we need to square it. So it's 8.591 squared, which should be 73.805. And then b squared, which, did we leave it? So this is b squared, so I need to put 345.538. And that, ladies and gentlemen, is your answer. Say it again. Our x is equal to a. Our x radius is equal to a. Is that what you mean? What do you mean by x? Our x is equal to a. Hang on. Let's look real quick at number 11. It's going to be easy, actually easier, but you need to know this word, perigee and apogee. What do those mean? Because this says, yes, for an elliptical orbit, the perigee is 25.693. The apogee is 87.245. So give me just 1 second. I think I have it here. Look closely. This is not what I meant to move. This is my asteroid. It's in orbit around the Earth. Obviously, at this point, it's in an elliptical orbit. Now, when an asteroid is right here, that's as close as it gets to the Earth. As close as it gets, which is delta, correct? Focus to, the Earth is at the focus, to the edge of the graph is delta, and that's the perigee, okay? Then, still didn't mean to move that. When my asteroid is way over here, that's as far as I get in orbit. That's called the apogee. I've given you a little hint. Apogee would be to the center, then to the edge, and so that's C plus A. Now, what if I just want to know A? true. And here, but I want you to think about this. What does the perigee plus the apogee,
C plus delta equals A.
what would the perigee plus the apogee give me? It would give me all the way across. Wouldn't that give me two A's? This A plus that A? So if I divide by 2, then A would equal the perigee plus the apogee divided by 2. We got it? You might need to know that.